Okay, hello everyone. In this short video, I'm going to tell you how to calculate the slope or velocity using a position time graph. The first thing to do is to pick up 2 points on the graph. Now, what are usually the perfect 2 points that we can pick on the graph? Um, you pick the points that are easy to find the x and y for them, the component x and y. So the position is on the y-axis and the time is on the x-axis. So I look at the graph here and I pick up 2 points where I can easily extrapolate from them to the y and x-axis and find the x component for it, or the time, and then the y component for it, or the position. So the best I can pick up like these two. Like if I put like this point here, it's easy to find the x and y for it because I can go right away perpendicular like that. So it touches the x-axis or the time perfectly on 4. And then to find the y component for it, I go horizontally like this, but still perpendicular on the y-axis. And then I can exactly find the y component for it, which is a 3. So let's put this like I'm as my initial point here. I have it here, so this is initially. And then the x for it is the time, which is 4 seconds. And then the y for it is the position, which is 4 meters. Okay. If you want, I can always like assign them. I would say, for example, okay, this is 4 here. I find it here. And this is 3 meters here. Then I mark it here. Okay. Then I need another one. The other one is supposed to be exact, like how I picked this one, easy to find the x and y component for it. So let me pick, for example, that one here. This is fine here. And then I do the same thing, and then I do like, I extrapolate perpendicular to the x-axis to find the time here. So which is at 8, so I put it here. I find it. And then I go vertical. Oh, sorry, hold on, let me just hold on for a moment. Okay, I'm trying to catch this thing here, this little line. Yeah, I got it. Okay. And then I go horizontal here until I touch the y-axis, and then that will be the position. So it's exactly at 4. And then I can mark it. So this is the final, or the second one if you want. And then I'll put here 8 seconds. Okay, the x for it is 8, and then the y is 4. Okay. After I do this 4 meters, after I do this, I'm almost done. So I put the values here. The initial time that I picked is usually 4 seconds. And then the initial position, which is 3 meters. And then I go, if you want final, here the final time is 8 seconds. Or the end if you want to say. And then the final position is 4 meters. Alright, and then the displacement is usually final position minus initial position. So I put these by their values. The final position is 4 meters minus initial position 3 meters. So that would be 1 meter. And then for the time, I put my final, which is 8 seconds, minus initial, which is 4 seconds. Okay, and that will be 4 seconds. Okay, so the slope is the velocity. So the slope is usually like, so this is here. So from 3 to 4 is actually my displacement. This is displacement here. Okay, from 3 to 4 it's 1 meter. You find it here. And then this is the elapsed time here, from here to here, which is the elapsed time. Okay, it is 4 seconds. So the velocity is the displacement divided by time. So all I have to do is I have to divide these two numbers. Okay. Okay, 1 meters divided by 4 seconds. Okay, and then the answer 0.25 meters per second. And this is how I calculate the velocity. That's supposed to be elapsed time. Okay, let me fix this for a moment. Okay, so this is the velocity now is 0.25 meters per second. And then if you can pick other points here, and then you notice that for any 2 points that you pick, if you follow the same procedure, you will find the slope is always 0.25 meters per second. I hope this helps. Thank you for listening.